Hello, everyone, and welcome to an exciting new episode of the Tek Caffe podcast, streaming live on LinkedIn and YouTube. I'm your host, Khaled ElNaggar. Today, we have two fantastic guest speakers, Maria Zulfiqar and Ahmed Misbah, who I will be interviewing on solid principles. Maria and Ahmed, thank you so much for being with us today.
Thank
Today's
you, Khaled.
episode,
Thank you.
thank you. Today's episode is sponsored by ActionGPT, a game-changing AI tool designed to enhance productivity during meetings. During meetings, lectures, and workshops, it provides real-time answers, automated summaries, creative idea generation, and ensures you stay on top of your tasks with actionable insights and deadlines. Learn more about how ActionGPT can transform your workflow here by scanning the QR code that will appear on the screen. Download the plugin and see how this tool is truly amazing. Before we kick things off, let me give you a quick intro to Tek Caffe. Our podcast launched in March 2023 with a mission to empower the tech community and spark innovation. In 41 episodes, we've hosted incredible guests, including Jeff Langr, Venkat Subramaniam, Paige Watson, Daniel Moka, and many others more, covering a wide range of topics, including extreme programming, TDD, software architecture, and AI. A big thank you to all of our guest speakers. This year, we're thrilled to announce a new partnership with the Riyadh Java user group. Stay tuned as exciting joint sessions are coming soon. Last year, we were proud to partner with the Startups Without Borders and Impact, as well as sponsor the DevOps Days Cairo event. To learn more about Tek Caffe, catch up on previous episodes, or reach out to us, visit our website. We're always excited to connect with you. You can scan the QR code on the screen. Now, without further ado, let's start our today's session. Today's session is about solid principles. But before we get into that, let me ask our guest speakers to introduce themselves. So, Maria, could you introduce yourself, please?
Thank you so much, Khaled. My name is Maria Zulfiqar, and I'm technical lead .NET in Pakistan. So basically, I have overall 11 years of experience as a senior software engineer in Pakistan, the professional industry. So I'm just passionate about the IT world. So in my, free time, I love to host different celebrities. I do collaboration online. I love to grow my professional network. So I had the luck. I was lucky enough to host different tech celebrities. For example, Kent Beck on my show, and I'm really grateful to Ahmed and Khalid, to you, that you invited me to your show. So it would be great, yeah, to discuss and share what I have, what I can bring on the table from my past experience. So thank you very much to you.
Thank you to Maria for joining us today. Ahmed, could you please introduce yourself?
Thank you very much, Khaled. So I'm Ahmed Misbah. I am founder of the Tek Caffe podcast. I'm also a chief architect with 20 years of experience in the software industry. Um, I'd like to thank Maria for being with us today. I'm a big fan of you and all of the content that you are delivering to the software development community. I would recommend to everyone that you check out Maria's channel and see her
Thank
different
you.
interviews with Kent Beck, Bob Martin, Daniel Moka, etc. And thank you for being with us on Tek Caffe
Thank
today.
you.
We hope to make the best out of this the topic of solid principles.
Thank you very much, Ahmed. It's been great honor and pleasure to talk with you guys and share with the community. That's how we grow.
Exactly.
Thank you, Maria. Yes, indeed.
Thank you.
So, away from any textbook definition, what are solid principles to you, Maria?
Uh, Thank you, Khalid. For me, away from the textbooks, solid principles are basically, that there's are basically the guidelines for you when you're working with softwares. They guide you to write clean, maintainable, and the scalable code. I highlight the importance of here the importance of the scalable code. So basically, that's how you are also of all structured software. For example, it's easy to understand for other developers. It's easy to modify in future, and that's easy to us for extend without breaking the existing functionality. So that's how they were introduced by Robert C. Martin. So basically, that's with these solid principles, we aim to reduce our code complexity, and we ensure that our code, stays robust and flexible. So for that's going to help you through you reduce the complexity in your code. That gives you flexibility to test your code. And the most important thing they offer is that they reduce the tight coupling between your code. And that's again leads us to better reusability, better error handling. And that's my definition of solid principles away from the textbooks. Thank you.
Very nice. That's very approachable. Ahmed, do you have anything to add on the definition of solid principles?
I liked Maria's definition very much. I just have a few more things to add to her definition. So, yeah, solid principles are a set of principles on object-oriented design. And when you understand them a little bit more than just the textbook definition, you learn that you can use them not only at the level of microarchitecture or what we call software design, you can also apply them to macro architecture, all of them or at least some of them. And as Maria said, they help you build loosely coupled, highly cohesive code for better maintainability and extensibility. Now, when I think of solid principles, I ask myself the following question. What would you rather have? Developers always giving estimates to business, big estimates, because every change is hard, or developers happily making changes that business requests because the changes are easy as they have clean and maintainable code. Now, solid principles let you achieve the second scenario. Now, the origins of solid principles. I like to talk about the origins because if you want to understand something really well, you need to go back to its origins. And Bob Martin first talked about solid principles in his famous book that was published in 2002 called Agile Software Development Principles, Patterns, and Practices. He describes these principles in the section that discusses Agile design. And what I like about the title of this section is that it couples agility with technical excellence. Okay, so if you want to be agile and you want to achieve agile design, solid principles are one way to do so. And the funny thing is that the solid principles are not all Robert Martin's inventions. You've got the single responsibility principle, open-close principle, and Liskov substitution principles. These were actually invented by other people. We attribute the dependency inversion principle and the interface aggregation principle only to Robert Martin. Okay, Robert Martin collected all of these principles into one nice abbreviation, and that is solid, and was able to promote these principles very well. But the thing is, that's why I want to talk about the origins, because if you want to learn more about every principle on its own, you might want to check the original writings by their authors. So Robert Martin was very honest about attributing the first three principles to their inventors. So you can always check the book and read about those. So yeah, that's what solid principles are to me.
Very elaborate indeed, Ahmed.
I would like to add that I really liked the last point of your answer, that when we have to understand one thing, we have to go back to its origin. I think that's the biggest point we should enforce things. So thanks for adding, Ahmed. That is a point I like the most. Thank you for adding. Yeah.
Yeah, the problem with software development is that people are always satisfied with whatever that is presented on the surface or on the shell,
Yeah.
and they fail to dive into the details and the origins, and by that they lose a lot and make themselves vulnerable to bad practices. So yeah, it's important that when we
Exactly.
learn the information at the surface, we need to always deep dive into things.
And also during my session with Bob Martin, he told me that to understand this everything in the IT computers, in the languages, the principles, just go 50 years back and understand the word for the computers. I really liked, and you were also relating that thing as well. So that's really very important for us, because we have, we are seeing what we are on the surface. We are not deep diving on what were the problem and who created the solution and why the solution was presented. Yeah, that's
Yes.
how our brain can relate the things and present us even newer ideas. Maybe we can create something from our own experience as well. So deeping dive to origin is really very necessary.
I fully agree with that.
Thank you.
Very well indeed. So the world of software design is so big. There are many principles. Where do you see solid principles fit in the big world of software design?
I
Maria?
think, I think Khalid, I think there's a big world of software design, and solid principles are always it can always give you the foundation for building the reliable system. I'm focusing more on the reliable system, because you don't want to give your client or customer a software that could only be short-lived for few amount of time or few years. You want to give them a solution that is long term. So the solid principles basically influence everything. Start If you start from your classes, for example, the solid principles. For example, if I just give you an example, it's if it tells you how your classes are structured, and just like Ahmed added that developers give you estimation on the things they will develop. So if the code base is flexible, and if really flexible on how components will interact within the architecture, so that's really going to help in maintaining that code base in the future world. So you can see the impact of these solid principles on the large scale systems design patterns, even the impact with their impact in the frameworks where maintainability and the scalability, for example, is very much important among teams, and it also contributes in the success of entire project in the team. So I think they serve as a great practical guide for crafting software that that is ahead, and that stands best to the testing and the complexity. For example, if you do not use them or you skip them, so there's a big world of software design. Maybe you are going really fast without them, but in the long run, your customer and eventually the company is maybe at the stake. So just give the developer, the structure. The developer must follow this in order to, going the success of project in the long term. So that's how I think about it. Ahmed, would you like to add something in this question?
Yeah, well, as Khaled said when he was reading out the question, software design is a very big world. So, in order to put things into perspective when it comes to solid principles, I think that the world of software design starts with quality attributes, okay,
Certainly.
what are famously known as the ilities, okay, or the non-functional requirements. Though if you read in some papers, some people say that the non-functional requirements are a subset of the software quality attributes. But anyway, When I think of quality attributes, specifically maintainability and extensibility, I think of software design principles in general. Keep it simple, you aren't going to need it, and all those kind of principles. And I did an episode previously in the same series talking about all of these principles. So part of that is object-oriented design principles, abstraction, inheritance, encapsulation, etc. And then you've got the concepts of coupling and cohesion. From these, you get solid principles, because solid principles are all about managing coupling and cohesion.
Exactly.
And from solid principles, you get design patterns, okay?
Exactly.
The gang of four patterns and the other design patterns. So this is where I see solid principles in the big world of software design. It's a way of achieving loose coupling and high cohesion, and it sets the base for software design patterns, specifically the object-oriented design.
Exactly.
Patterns.
That's
very elaborate answer, Ahmed. Thank you. So moving on to the next question. Why are solid principles important, and why should we even apply them?
Yes, exactly. I think this question relates to our previous discussion as well. They are really important because the solid principle always promote the better software design. For example, we always talk about that the code should be easier for others to understand. They promote this idea of making code easier to understand, and obviously if it would be easier to understand, it will be easier to maintain it, it will be easier to extend it. So if you follow these principles, they are really going to help you prevent the most common issues, like we say that code rigidity, the the static code being used, the fragility of the code not able to reuse in other parts of the software. So you often experience the software where changes in just one part of the system unexpectedly impact the others. So developers not knowing what's happening, so they basically encourage building such systems that are if I say the proper word, the modular, then they are testable. They will save time for the developers, the future developers that are going to work on it, whenever they are adding new features, whenever they are making changes without the risk of introducing bugs. So Ahmed, would you like to add something?
Thank you very much for this answer, Maria, and I fully agree with what you've said. And actually, what I wanted to add is complements what you've just said. I want to talk about Constantine's equivalence. This is something that Kent Beck talks about in his recent book, 𝗕𝗲𝗄𝗏. And Constantine's equivalence basically says the following, that the cost of software equals the cost of its change. And the cost of change is equal to the cost of the big changes. And the cost of big changes equals how much coupling you have in your software.
Totally agree.
Therefore,
Exactly.
the cost of software equals coupling. And yeah, so that was basically what Maria was saying, is that solid principles are important because they're all about making code easier to change, okay? Because when code is easier to change, then you have the cost of software put under control. But
Exactly.
when there is high coupling, therefore you have high cost of change, and therefore basically the cost of your software is huge. And this is what usually leads to systems being dismantled and replaced by other systems. It's the promise of ease of change and the reduction of the cost of change. That's always the promise. And if you want to be able to deliver on that promise, you need to start applying some technical excellence and solid principles are a way of applying technical excellence.
I totally
Very
agree
well.
with this. Exactly. Very totally agree with this.
I think it's right to connect it to change, as if you have a project that isn't actually changing, it's a dead project. In this time and age, we
Yeah.
have changing requirements for
Yes.
new customers and the new markets, etc. Now that we've talked about what solid principles are, how important they are, can we talk about how many people understand the solid principles, but they don't know how to apply them? So what
Yeah.
is your recipe for applying solid principles, Maria?
Thank you, Khaled. This is, I think, a really important question you have highlighted. So I think that my recipe for applying the solid principle is write the code with some, write the code with some intention, and be mindful when you're writing it. Focus on, for example, focus on start small. Don't just jump and apply every principle every time. Just start small. Focus on, you can always, if you are refactoring your code base, you can always focus on once. Maybe you can also focus one principle at one time in your project. So for example, if you talk about single responsibility, you can start with ensuring that your class has a single responsibility, and without worrying about the other principle at the moment. So again, you can refactor continuously your code, and you can check that, look for the areas in the existing code base that are actually violating the principles, and factor them iteratively without breaking the existing output or existing behavior. So it's all easier to apply the solid principles when you are starting the small. Also, if you, one of the most important thing that I want to enforce here or highlight here, with the developers, if the code you're writing, the confidence is really important on whatever you have written. So we have the common process in the software world that developers develop the code, and the tester tests, the QAs perform the testing, and that goes to POs and then goes to client. So the confidence of developer is really important. So one of the things that I would like to mention in write tests, at least write tests before you actually start implementing the code. Because writing tests forces you to think about how your code can be that it is giving you why part behind the client requirements. So you can always test the practice test driven development. That's one of the most important in my recipe. So because they are all easily make you towards applying these solid principles and other principles along the way. So that's one important thing to shift your mindset on the code testing as well, and then write tests, and then apply solid if you're going towards principle one by one. And if you're a beginner, you have problems in applying single solid principles, you can always get feedback from your team, your peers, and you can reveal the areas where you have applied the solid principles, and where they can, the other team members can reveal areas where they can be applied better. And I think collaboration encourages you to use the best practices. So I think that's the recipe for anyone who is starting with these principles.
Very well. I like how you said we start small with a few principles, apply them, write tests, and get feedback. They're very approachable. Ahmed, would like to add anything to this?
Maria has said it all. So I do have a 4-step recipe. And what's common about my recipe and Maria's recipe is that they both have TDD as an ingredient. So my recipe is basically 1 read, 2 TDD, 3 katas, and 4 measure. So what does this mean? So read means that, as we've said, answering your first question, Khaled, is that you have to read about solid principles thoroughly and understand them, okay? Because you will never practice something and practice it really well and be able to know how to practice it unless you understand it, okay? In Arabic, we have a saying, 𝗕𝗲𝗏 لا يعطيه. in English, that is, if you're missing something, you will not be able to give it, okay, because you don't have it. So if you don't have the knowledge, how will you be able to deliver with solid principles if you don't know what solid principles are all about? The second step is TDD, okay, and that was the best thing about Maria's answer. So TDD makes you write tests as a safety net. It encourages you to design and refactor, because that's one of the phases, and it encourages you to work small, as Maria has said. Okay, so TDD is really the recipe. And there is one thing I want to talk about here, and I think we will be doing a session for that next year to talk about it more thoroughly. What I like about TDD is that in the green phase, you write terrible code intentionally, okay, in the green phase. And then when it comes to refactor, you are starting to think about design in how to make this code better. That's much better than starting with nothing. So if I tell Khaled or if I tell Maria right now, here is some requirements, do the design for me, and you have a blank sheet of paper, it's going to be a little bit hard. But if I tell you, write some crappy code to achieve these requirements, and then I tell you, fix the code, your job is going to be much easier. We are much better at fixing things when it comes to code, of course, than designing something from the beginning. Okay, so this is what I like about TDD. Okay, it's natural, it's easier, okay, because I have something to start from. I have bad code which I want to make better. That's better than having no code at all. And then, what design, how can I apply solid here? And there's an empty editor in front of you, okay? Third, practice on katas. So no matter how much you read, you need to practice to build the muscle memory. So katas are a good way to do so, and measure. Measurement is a way to know if you're on the right track or not. So try to measure using the DORA metrics, by simple metrics to measure cohesion and coupling. You have to have something that would tell you that whatever solid principles you've applied are really working for your code.
Very well and extensive, Ahmed. Thank you for the
And
answer.
thank you, Ahmed, for your answer. I would also like to add that I asked the Robert C. Martin what made you a better programmer. He always stated that when he followed TDD, he was great programmer after that. So when we see a view of the, like Kent Beck or the technical celebrities, which were on some, which really did something for the community, you find everything common in between them, that they were great programmers were by shifting their programming mindset to the testing. So when you are confident on your code, you are no under stress. Your client is happy for example, from your code, and that's how you get promoted. Even if I talk one-to-one from the client, they always say that the developer must know the why part behind that. They don't just get the requirements and start coding. Just think how customer is going to use it. And most importantly, it's really, really great technique to get the code confidence. So I agree with you, Ahmed, and I urge others to start taking small steps towards at least trying TDD.
Actually, there's one interesting thing to mention here is that when we wanted to do a session on solid, the original plan was to just me and Khaled do a session and all of that. But when I saw you did interviews with Bob Martin and Kent Beck, I was like, now here's a person that has the information from the source. So we want that person to be. So every time you mention Bob Martin and Kent Beck, I say, that's information coming from the source. Okay, so mashallah, that's something that is going to bring a lot
I
of
think,
richness.
yes, I think, Ahmed, there is no rocket science to reach. People on LinkedIn ask me to how you approach them, how you reach them. I think it's the passion that connects you with the people. If you have urge to, if you have urge to know the why part of what they have written in their books, and you are implementing, you have some questions. If it's the passion, or you can say that the law of attraction, if you have something you are passionate about, that is going to connect you with them. There is no hurdle beside, so you should be curious. The first law is that you should be curious. Otherwise they are not, easy. They are very easy. Yeah, they like people who do hard work and then go to them. They don't like people who just approach them with no knowledge, or you just wasting their time. So they really like the people who do hard work. So if you're passionate, you're curious, anyone can have them, anyone can easily talk to them. So anyone can learn from them directly.
Agree. Passion really makes you, reach new horizons, as they say. I'm
Exactly.
not a big fan, and I'm not a believer at all in the law of attraction, but I do believe. When you're passionate about something, this
Yeah.
gives you the motivation to try and do the effort to reach whatever target that you want. So it's something
Exactly.
that is inside you, um, away from any laws of attraction. Now it's a matter of opinions, but I'm strongly opinionated regarding that. I don't believe in it.
Yeah, I
But
asked.
I
Yeah, I
do
asked.
believe
Yeah,
that passion is a strong motivator towards things.
yeah, I asked Uncle Martin that why you talk to me in interviews and not the rest one. He asked me. He just told me that you approached me, you emailed me, you contacted me. I talked to you. You were passionate. That's how I talked to you. If someone else, there's a simple recipe. Be curious, be passionate. Then you can do anything in this world. You just besides this approaching these technical celebrities. I know that's a good thing, but you can achieve anything if you're curious about anything. Yeah.
Yeah, it's. I think you've reminded me of the famous saying, "Love what you do."
Yeah.
So I think that this love that you put in your work also can take you to new horizons, as they say. Yeah.
Thank you, Ahmed.
Absolutely.
Yes, exactly. Absolutely, you are right.
Yes, passion and hard work goes a long way. So we can move on to the first principle in the solid principles, where the S stands for single responsibility principle. Now, Maria, could you briefly explain the single responsibility principle and why it is foundational to solid?
Exactly. So, Khalid, the single responsibility principle is basically, you can say, the first principle of the solid that states basically that when you are designing a class, that should have only one reason to change. Means that it should do one job. It should do, it should have one responsibility. So, it is foundational to solid because uh, why we say it's foundation, because it's just do or just lays the groundwork of the modular and the maintainable code we were talking about during this session. So by ensuring that if your class handles a specific responsibility, then this single responsibility principle is promising you that it's going to reduce, the complexity. The code would be easier to understand, and basically you would have the less risk, or it minimizes the risk of unexpected side effects when making the changes to the class. So it also, what we have observed during our work, that it also makes testing easier. Testing, it makes testing more straightforward. So as issues are localized to smaller well defined areas of the code, so that's, I believe that it really helped us in testing and debugging. So that's my definition of single responsibility principle, and how, why it's foundational to solid. Ahmed, would you like to add something to it?
Thank you very much, Maria, for that. I have just a few things to add. Thank you first for mentioning that a class should have only one reason to change. That was actually Bob Martin's description in Agile Software Development Principles, Patterns, and Practices. I want to add two more things, okay? If you find it hard to understand what Solid is all about, the very simple description is cohesion. Actually, the inventors of the single responsibility principle, Tom DeMarco and Miller Page Jones, they simply described it as just cohesion. Okay, so what is cohesion? It's basically when you look at a class or a function, it does exactly what it's supposed to do, and it only does that. If whatever code you're seeing meets this, then you're doing single responsibility. Bob Martin, in his book Clean Architecture, also describes single responsibility principle as a module should be responsible to one and only one actor. And I think in many of his videos, he gives this as an example. So he says, if the business guy from the payment domain asks you for a change, then it shouldn't be this, the place where you're going to be doing this change shouldn't be the same as when the database guy comes in, okay? These two actors should have changes being done in two separate places, okay? So this is basically, I think that the simple way of describing the single responsibility principle is high cohesion. As simple as that.
That's simply straight and short, simple and straightforward. Yeah, exactly.
Yep.
Yeah, thank you, Ahmed. We move on to the next question. So how do you approach designing or refactoring code to adhere to single responsibility principle without overcomplicating the design?
Okay, Khalid, I basically focus on simplicity and clarity. That's my first approach. For example, identify the responsibilities. Start by reviewing what's the purpose of class. So review the class, to understand its responsibilities. Check that if your class is handling multiple concerns. For example, your class is it responsible for managing data, or it is responsible to do some other complex calculations. So then you split them to to their distinct purposes. So that's the first approach to identify the responsibilities. Then instead of doing everything together, you break responsibilities one at a time into smaller more focused classes. So you prioritize these changes, then that simplify your code. The idea is the simplicity. Identify the responsibilities and do the simplicity in your code. Resolve clearly the pain points in the start. So also I would like to focus on that the name, give meaningful names to classes. Often we work with the code bases where the names are not meaningful. So I think that if we focus on giving the meaningful names to the classes and methods especially, that reflect their single responsibility. I again say that the method names or the class name, you should reflect that, okay, I am going solid, I am following the single responsibility principle. So the name also reflects the idea. Okay, because the clear names helps us guide the design and communicate the intent of the code. So no, if a future developer is going to come and extend your code or watch your code, he should know the intent of the code. Also, I believe that keep it practical. If splitting responsibility introduce unnecessary complexity, it's okay to pause and reconsider your your what you have performed. So I think the right balance is necessary, and that comes within experience or trying out different options. There should be a balance between readability and maintainability and over engineering your code. Also think that do everything, whatever you're doing, do it wisely. So I think by following these steps, anyone can apply SRPE thoughtfully, and you can enhance your code quality and I think that could help us avoid unnecessary complications.
I agree. They're very approachable steps to start reading and designing, etc., and not blindly applying the principle. That's very important. Ahmed, would you like to add anything?
Okay, so one of the ways I like approaching design and refactoring to adhere to the single responsibility principle is to look for a very famous code smell, and that is the large class. Okay, so whenever I see a large class, I immediately form the impression that it definitely has a lot of things that are not related, and it needs to be broken down. So the first thing I start with is to search for the different responsibilities that the class does, so that we would separate those from each other into one cohesive unit. So let's take as an example, let's say I have a class that has the presentation logic, the business logic, and the code that talks to the database all in one class. It's a no-brainer. You have three responsibilities here: the presentation, the data access or the repository, plus the business logic at one place. So you at least need to start with breaking these into three separate units, so that each unit would have a single responsibility. And of course, for that, you can apply any form of hexagonal architecture, MVP, MVVM, and similar patterns that allow you to achieve this separation of concerns. Now, if you find different business logic in one place that is not really cohesive, so you separate this business logic from each other using the concepts of domain-driven design, the tactical patterns. You separate them into entities or whatever. And you look at the end result. If you have small classes and methods that do one thing and have only one reason to change, then you know that you've done the right refactor to this code. So that's my approach. It's a very simple approach, and of course that's not the only approach, but usually when you see some big method or class, this is always an indication that something is wrong with the single responsibility principle being applied.
Exactly, and that really, Ahmed, I would like to add that that really affects your work. For example, if in the hurry you don't, I have also worked with the JavaScript file that has 6,000 lines of code in just one, just one. There was such a big class, unnecessary, functions doing more than one thing. That was really hard to maintain. So whenever you should develop code in a way that when you leave and someone else come, that shouldn't curse you. Okay, you delayed my releases. Because of you, I'm going to constant carryovers. My tasks are not completed. The client is not happy with me. I am hard worker. I know everything, but how do I change your code? So I think if you that's really terrible experience. Have you ever had this experience? Because recently, a few months back, I had that experience of managing someone's code, and that was class was doing so many things that we find it really difficult to change it. So that's how you get depression, you get stress, and there is only way to avoid this is to refactor it. Then you stop here, you take time and outside of your development hours, you took because client is not going to pay you again for the same task. He doesn't know that you have done the bad code. He's not going to pay you. You have to refactor it then. So I think that's really, really important for you. Please follow these things so that if you leave, someone may not come into your place and curse you back that, okay, what have you done? So do this at this point.
Yeah.
Very true, Maria.
Yeah.
So we hinted about overcomplicating things. Now, can single responsibility principle lead to many small classes or functions? And how do you find the right balance, Maria?
Exactly. Exactly. That's, I think, a really important question, because we talk about single responsibility, and that idea is that a class should do one thing. But yes, when you rigorously apply a single single responsibility principle, that can sometimes lead to too many classes of functions if you are, for example, trying it something as a beginner, which is also very bad, which, because it's going to make your code harder to manage if overdone. So yes, finding the right balance is very important. For example, you can always identify the related behavior when you are splitting up your responsibilities. For example, you can always relate the you can always ensure that the related the functionality is still grouped together in a way that makes sense contextually. So you don't do the overcomplication here. You can, just make unnecessary classes if the related functionality could still be done in one class. So you just don't split so finely that you lose the logical flow of your domain model. Again, that's upon your whatever your what domain, that depends upon the logical flow and the domain model of your application. Also, I think, again here, if separating concerns improves, I think readability and makes maintenance easier. So it's always worth creating additional classes. And however, if it adds unnecessary confusion or complexity, then always seek support from your peers, or consider combining responsibilities where appropriate. Use your critical thinking over here. Also, you can review your domain logic on specific problem you're working on. You can always use your problem domain to guide your design. That's really important here. So you can always, if a class naturally represents a distinct concept in the domain, and it should have its own responsibility, keep otherwise keep it simple. And don't go for over premature optimization, because our goal is to create clean, maintainable, basically understandable code base, where the organization of classes and functions feel natural and related, rather than forcing SRP everywhere at the cost of clarity. So that's how I perceive it. Ahmed, would you like to add something?
Oh no, I think you've said it all. I think that, as we've said at the beginning of this session, design patterns are the implementation of the solid principles in object-oriented design. So I think that if you're able to identify the right smell in your code and apply the right solution for that, and you've got many guides for that, the refactoring book, the refactoring to patterns, and all of these books, and clean code, of course. So don't reinvent the wheel. Okay, so identify the right smell, apply the right design or architecture pattern, then you should achieve this balance. Okay, because the problem with bad code is not a new problem. Okay, and it's how do I say it? There's really nothing new about it. Okay, people have been writing the same
Yeah,
bad code
exactly.
for many decades now. So basically, don't reinvent the wheel. Just spot the right smell based on some principle. Apply the right pattern. This should help you achieve the right balance. And of course, as you've said, sometimes you need to use your head, apply critical
Yeah,
thinking, and all of
yeah,
that. So it's not always a no-brainer. Sometimes you need to think it over so that you
exactly,
wouldn't complicate things. Yeah.
exactly.
Yes, I think that applies to all the principles, that if you overdo them or if you overcommit to them, that's going to fire back with really bad designs. So we talked about the single responsibility principle. We move on to the open closed principle. So what does it mean for software to be open for extension but closed for modification, in practical terms. Can you explain that, Maria?
Thank you, Khaled. So for me, it means that when a developer has written a class or once some module is written, you should be able to extend it, right? Its functionality without changing the existing code. So I'm going to tell you why behind this, because instead of modifying the original code directly, you can always, be able to add new functionality through, for example, if I talk about interfaces. So in practical terms, extend your code without, you should be able to extend your code without modifying existing. For example, if I'm working on a code base, when I need to add a new functionality, for example, or I'm changing behavior, I should be able to extend the existing class or module rather than altering the entirely already tested and working code. So I should not be, be disturbing the already tested and working code. For example, you can always go and introduce, for example, new class for new behavior. Why I'm saying this? Because maybe your new class is designed, for example, you are designing a class to suit that problem at hand you have at hand that was not before. And the benefit is that you are using a new class and nothing in the current system depends on it, you know so you can add the behavior without touching the existing one. And again, that we were talking about single responsibility principle, you are actually applying, actually following the single responsibility principle here. Again, your new class can be unit tested really well. So I think that's how, that's my idea, and that's what we've been working, is that introduce new classes without, behaviors, without altering the existing code base. So that's my definition of open close principle.
What about you, Ahmed? How do you define the open close principle?
Well, I think I have nothing to add on what Maria has said. Basically, if you find yourself adding new stuff rather than modifying existing stuff, you should be on the right track.
Very well, Ahmed. So why is this principle important? What are the implications of not applying it?
Okay, I think the biggest benefit, one of the biggest benefit is easier maintenance, Khalid. Whenever new requirements, client has new requirements or new feature arises, you don't have to modify your already written existing code. Instead, you are able to extend it. That makes sure that existing functionality is stable, and you are nowhere introducing bugs into already working code. For example, it's also supports you in better testing of your new behavior or new feature. And I think if you're not applying it or not using it, that can increase the risk of bugs in your code. And maybe you are changing behavior in existing classes, there's a chance that you are tightly coupling your code, and you are not, that would be a poor testability. I think the major important point is the testability. So I think if you're not doing this, then you can always have the chance of bugs, and you are not able to, the things will be difficult to track if you're not doing this.
Yes, yes, indeed, Maria. Ahmed, do you have anything to add, or?
Okay, so I would say that if you don't apply the open close principle, you risk having high coupling, low cohesion, and even violation of the single responsibility principle. Okay. And it could also lead to having large classes or even large methods, okay, which are a code smell. So yeah, these are the implications, and that's why it's important to always think of this principle when you are writing code.
Very well, Ahmed and Maria. So how do we handle situations where a code base requires frequent changes that might seem to violate the open close principle?
Yeah, I think, Khalid, this really nice question. You often encounter changes where frequent changes that might seem to violate your open course principle, that can often be accommodated by using different techniques, like you are following modular design, you are using, for example, abstraction, and you are using the right way, you are using dependency injection or other different patterns that they're offering. So instead of modifying existing code directly, you can always introduce new functionality by extending, I think, or composing classes and using flexible the design techniques. So this allows, I think, to code bases to remain open for extension while still being closed for modification. And in the long run, they will be maintaining flexibility, they're reducing risk and improving the maintainability. And I think that if you deep dive, you can always add new behavior without disturbing the previous ones. And with your experience and working, you can always find the balance of this between them. For example, use the correct use of interfaces to classes, or you define extensions. From these techniques, you are able to add your toggle new features of flag without modifying the core application logic or disturbing other features. Ahmed, would you like to add something?
Uh, okay, so I would say that it all comes down to separation of concerns. Okay, so if you're presented with a situation where you have frequent changes and for some reason you always have to modify the same code, I would recommend applying a pattern like strategy or the observer pattern, so that you would, extract or abstract away the parts that change frequently and extend them as needed, minimizing the changes to the
Exactly.
core.
That's right. That's really right.
Yes, we are back again to the importance of reading about the different refactoring techniques and reading about these principles, so we can have a tool set of refactoring techniques and code smells to look for and fix using refactoring techniques. Thank you, Ahmed. We move on to Liskov substitution principle. Maria, how would you explain the Liskov substitution principle to someone who is new to Solid?
Okay, thank you, Khaled. So my definition for Liskov substitution principle is that it basically says that the objects of your superclass should be replaceable, with the objects of its subclass without affecting, the correctness of program. The correctness of program is here the important factor. So why it's important and why I say this, because Liskov substitution principle says that it promises that your subclasses adhere to the expectations set by the parent class. So that versus benefit, it's going to make your code more predictable. That's a very important point. That's going to make your more predictable and extensible. And if you don't follow the Liskov substitution principle, you might end up with the code that behaves inconsistently under certain conditions, or may cause errors when trying to substitute that different objects in your code base, which can be later on difficult to debug or maintain. So I think the idea of is that the objects of your superclass should be replaceable for the every behavior. There should be the subclasses that should be replaceable with the your subclasses. So that's how I defined it. Ahmed, would you like to add something to it?
No, actually, you've said it all, Maria. Thanks a lot.
Thank you.
Yeah, that's a more approachable definition than the duck example that's related with the Liskov principle.
Thank you.
So what are the consequences of violating Liskov substitution principle, and recognizing these violations? How do you recognize them?
Exactly. The first consequence is that your code is for sure going to have unexpected behavior bugs, because if your subclass does not behave as expected based upon its parent class, it can lead to unexpected behavior. If I tell you example, for example, if a subclass you're using alters the expected behavior of a method or introduces error, substituting the parent class with the subclass may cause the application to fail or behave incorrectly. And how do you recognize, for example, first of all, you are going to have unexpected exceptions or errors, and you can have the behavior and inconsistency. And how fix them? For example, you can see that if in your code base, you can always there's a pattern, null object design pattern. Please go and read about it, and minimize your code with the what we have used, or see that these patterns really help you go through it. And also, when a subclass raises some exceptions or behaves incorrectly in a ways that they're not expected by its parent class contract, it could indicate the violation of Liskov substitution principle. That's how you recognize it. For example, if you're substituting a subclass for the parent class, we said that it should behave, or it is expected to behave like a parent class. So it will going to cause you an exception that wouldn't occur with the parent class. That's a red flag. So that how first of all you recognize it. Or also, if your subclass methods doesn't behave consistently with the parent class, either by changing the method signature, or maybe you have altered some logic in an unexpected way, that can also indicate a violation of this. So these inconsistencies, Khalid, often shows up when you use the subclass in place of the parent class, and then the system behaves differently. So I think that's how I recognize them or fix them. Ahmed, would you like to add something to it? How you approach these fixations, or these unexpected behaviors when you recognize the violations of LSP?
Yeah, I think that let's go a step back, okay? When we say parent and child classes, we're talking about inheritance, okay? And inheritance, if not properly, if it's not being properly used or implemented, it is known to make things, complicated and hard, okay? That's why we have a principle called favor composition over inheritance, for example. So I would say that since we are talking about inheritance, so if you violate Liskov's substitution principle, you end up with having bugs that are hard to trace. Okay. And so, yeah, and when we talk about code that is hard to trace, meaning it's hard to find where things are going wrong, we're talking about bad code that is not maintainable. Okay, so yeah, I would say that if you violate this principle, you're basically making your code less maintainable by making bugs harder to trace and find, because of the nature of inheritance in general.
Yes, indeed, Ahmed. It's important to not have any undocumented side effects, or have missing behavior that should have been guaranteed by the parent class. All these
Exactly.
fall into the violations. We move on to the interface segregation principle. What is interface segregation principle, and why is it important, Maria?
Okay, thank you, Khalid. Why is interface segregation important? Because when you design or create fat interfaces with large, and blotted interfaces that have too many methods, you have obviously observed when we create an interface and put every method into it, most of the time, which may not be related as relevant to this implemented classes as well. So if a class that is going to use that interface, which may have 10 to 12 methods, if class is forced to implement methods it doesn't need, then it leads to your code bloat, and which makes the system harder to maintain and understand for other one. For what will you end up is that if even if the class is not requiring that method, that is forced to implement, write some extra code, or maybe a exception handling, or not implemented exception or something, because you're forced to implement it. You have the large interface, and your code uses just there is class is basically forced to implement it. So it basically advocates that it's always advisable to split your large interfaces into smaller, more focused ones. That's what this principle is about, because that caters to specific client needs. Okay, ensure that each interface has only the methods relevant to class implementing it. So I think this makes the interface easier to implement and understand, and also you reduce unnecessary dependencies, I think. So that's really important. Don't when you are seeing the large interfaces, fat interfaces, these principles state that be more relevant and be more precise with that. So that's my definition of it. Thank you.
Ahmed, yes, thank you, Maria. Ahmed, do you have something to add?
Well, I would say that the interface segregation principle is basically applying the single responsibility principle to your contracts or interfaces. Okay. So, because an interface is a contract. Okay.
Yeah.
So, I want this contract to be cohesive. Okay. So, yeah, but because if I have to implement a contract where I just need a few of its interfaces and I don't need the rest, then there's definitely a problem with cohesion. Okay, and I need to do this separation or this segregation. So I would say, in very simple terms, this is the SRP of your contracts in the code. And one funny thing to mention is that because this principle was violated in so many frameworks, we got the dummy objects as one of the patterns or types of test doubles, right? Why do you have dummy objects? It's because you've got an interface that forces you to implement
Yes. Yes.
20 or 30
Yeah.
methods, and you wanna just write a simple test that depends on this, and you don't wanna implement all of these. So that's why they invented dummy objects for that. So I would say that if the interface segregation principle was applied properly, maybe we wouldn't have needed the dummy object when it comes to implementing test doubles. But anyway, yeah, it's SRP for interfaces and contracts.
Yeah,
Very
that's
well,
great
Ahmed.
addition. Yeah.
I think also separating interfaces helps with composition. If you have two interfaces and you need only the first interface, you can extend it or implement it. If you need both interfaces, you can implement both. So there is no
Yeah.
need to have them in a single fat interface.
Exactly.
So we move on to the last principles and the solid principles, which is solid dependency inversion principle, the DIP. So how does dependency inversion differ from traditional object-oriented programming practices, Maria?
Really, thank you, Khalid. First of all, let's try to understand this principle, the dependency inversion. So it basically says that your high-level modules, should not depend upon your low-level modules. So for the beginners, I would like to give the detail what is mean by high-level modules here and what is mean by low-level modules here. So high-level modules concerns may contain your business rules, your processes. They are far from how input is coming out, etc. And for the low-level modules, try to understand it that they're closer to your input-output operation on your low level, or you can say plumbing code that interacts with the system and hardware. So they should not be tightly coupled. They shouldn't be dependent on each other. So how now coming to towards your question is how this is different from traditional practices. So I think that it differs from the traditional techniques or principles is that we are inverting the direction of dependency. We are saying that high level modules should never depend upon low level modules, but they should depend upon those abstractions. So what I mean is that it encourages your loosely coupling. We have been talking about everything about these principles, everything, your win is basically you have a loosely coupled code. Your things are not tightly coupled to each other. Your code is flexible, maintainable, and testable. So if you're adhering to this principle DIP, you are reducing the risk of tightly coupling basically, and you are making your code more adaptable, more easy to test, and thus enhancing the long term scalability that we were talking in the start, that is really important for the sustainability of your company or your software system. So I think the bigger, if I talk about example, is that tight coupling versus loose coupling in the traditional loop techniques. Maybe somewhere you were able to, somewhere you were encouraged to do tightly couple your code, where classes might be in some scenario directly dependent on one another, which is always the very bad practice or increases the risk of fragile code. And in the wrong, then your code will be definitely harder to maintain. If you use dependency inversion principle, that basically promotes your loosely coupling between classes, because it ensures that your high level modules and low level modules are not dependent on each other, but they are dependent on some kind of abstraction. So that of course makes your core system more adaptable, more robust, and reducing the risk of breaking any functionality when introducing or changing a specific implementation. So I think that's how it differs. Ahmed, would you like to add something to this question? This was a really nice question.
Yes, indeed. I fully agree with that. Uh, I think again you've said it all. Maybe if I'm going to summarize what you've said, so in traditional object-oriented programming, the high-level modules depend on the low-level modules. This is the way it works in object-oriented programming. So, but this can cause coupling. Okay, so dependency inversion principle reverses that. It makes, or it instructs you to let the high level modules depend on abstractions rather than the lower level implementations of the low level module, so that you would decouple these pieces of code from each other, so that if you have to change any code in the lower level modules, that wouldn't affect the higher level modules at all, because they're depending on that abstraction.
Yeah, exactly.
I like the distinction that Maria made about the high-level modules, the business logic, that it doesn't have to know about the low-level modules, which are the
Yeah.
frameworks that could be changeable, that are sort of dependent on, for example, databases or certain network interfaces, etc. Your business logic doesn't have to know about them, doesn't have to be tightly coupled to them. So it's important to apply such a principle.
Exactly.
So we move forward with how does dependency inversion principle improve code flexibility and decoupling, Maria?
Exactly. As we stated, Khalid, that by following DIP, you are promoting decoupling. That is really important, part of it, because you are promoting decoupling, because you are ensuring that high level modules are depending upon extractions, for example interfaces, instead of those concrete implementations, and tightly coupling of your DB context with your code. For example, I'm taking example. So this allows easily replacement of low level modules without affecting the higher level logic. So when you promote this loosely coupled code, you achieve better maintainability. For example, using this for example, if you use dependency injection, for example, and dependency inversion principle makes your components more adaptable. Again, it will in the long run, that is going to help you simplify your testing and minimize the impact of changes. In short, if I summarize this question, I would like to say that this enables you to swap implementations. That's what you were also talking about, Khalid, without modifying the core business logic. So I think that will be in future lead you to more flexible and reusable code. That's how uh, I perceive about it. Ahmed, would you like to add something to this question?
No, again, Maria, you've said it all. Thanks a lot.
Very well.
Thank you.
Thank you, Maria. So finally, is dependency inversion principle inversion of control and dependency injection. Are these all the same thing, Maria?
Yeah, that's really a nice question, Khalid. I would like to answer it as that dependency, DIP, that's what we were talking about, dependency inversion principle. Basically, it's about idea of decoupling your high level and low level modules via abstractions or interfaces. Okay, when we talk about inversion of control, we say it's as it's basically a pattern, a design pattern, which gives us the developer the control over the flow of how the flow is inverted. And for example, it helps if often used to manage the objects creation. And when we talk about dependency injection, it's basically our technique to achieve that, inversion of control by giving you flexibility to inject dependency into your classes, and again giving you a more loosely coupled code. So when your classes are directly communicating with each other in a class, I'm gluing the new class B, for example, B class object new into B. So I'm creating a tightly coupled approach. So DI basically is the technique, to achieve that inversion of control by injecting the dependencies into the classes. So I think that's how they are related. Ahmed, would you like to add to it something?
Yeah, so there are two parts to Khalid's question. So the question was, are the three, the dependency injection principle, inversion of control, and dependency injection, are they all the same thing? Because, yeah, a lot of the time when you hear developers talking, they use these terms interchangeably as if they mean the same thing. One very simple answer: no, they are not the same thing. So dependency inversion and inversion of control are both principles, and they are different principles. Okay, they are not the same principle. So and the problem with inversion of control is that the term is very technical, but it has another term, and that is the Hollywood principle. Don't call us, we'll call you. Okay. So these are different principles. Dependency injection is actually not a principle. Dependency injection is a design pattern. Okay. And when implementing this design pattern, you are following the dependency inversion principle and the inversion of control principle. But the three of them are separate things, totally separate. And 𝗕𝗏𝗏𝗀 has published a paper a few years ago talking about the difference between all of these concepts. So maybe we can share that in the comments after the session, so that people would be able to distinguish the three concepts from each other. But the simple answer is no, they're not the same thing.
Very well, Ahmed. I think we've covered the solid principles to a great extent now. We can move on to the Q&A. For everyone watching us, feel free to leave your questions in the comments on LinkedIn or YouTube. I think we have a question by 𝗕𝗏𝗏𝗀𝗏. 𝗕𝗏𝗏𝗀 is asking, is there a limit to how many lines of code a class can have?
Very tricky question.
Yes, indeed. Maria, would you like to go ahead?
Yes, there is always, I think there is not a strict rule about the number of lines a class should have, but we should always, go to best practices. It suggests that best practices always suggest you that keep classes small and focus to improve the testability and maintainability. And also that's always going to help you with the readability. So that's all we talked about. Say for example, I relate the single responsibility principle to this question. Like if your class is growing too large, then it always means that it's doing multiple responsibilities. So that's how you judge you are violating the SRP. So that's first point to consider, that if you are violating SRP, quickly split up the responsibilities. Or also, I think our large classes doing different responsibility are very difficult to understand. For example, as I told you that a few months back, I was working with the class that has more than 600 lines. Another class have more than 5,000 of lines of code. That was a very rough limit. So I think there is no specific, Ahmed, I cannot say how many lines, but I think that's go with the responsibilities. Yeah, you identify that. You
Yeah,
judge it by responsibility.
I fully agree with that. Now there is a rule for methods. Okay, I think there is an agreement that a method should be around 5 lines of code.
Yeah.
Yeah, there's this rule for methods. For classes, I remember one rule. It said that the first rule of classes is that they should be small. The second rule of classes is that it should be smaller than that. Okay, so the rule is to keep them small, and to keep them cohesive, as you've said, Maria. And look, Kent Beck has the rules of simplicity, okay? And I think the fourth rule was that you shouldn't have too many components in your code, too many methods, too many classes, but as long as they follow the other three rules, okay? So here's the thing. If you feel like you have a very big class, okay, because it's hard to read, it's hard to maintain, whatever, and of course, definitely you're going to extract it, okay? So you're going to extract it to a different class, or perhaps move the logic to a different class, whatever. Just give it some thought, okay? Is this really worth it? Is it going to improve readability, maintainability, and is going to keep the code simple and clean? If so, then you're on the right track, okay? So basically, there's no rule. We can't give you a number like the way we can with methods. But as long as all of the methods in this class are supposed to be in that class, and they're not supposed to be extracted anywhere, then the class is right about, is the right size, okay? But we don't want classes that are 600 lines of code, as Maria. Every time Maria says that story, I want to laugh, because I can imagine the situation. So we don't want 500 lines of code and 1,000 lines of code in a single class. We want it to be less than that, but as long as you're not splitting the code so that you would have very small chunks, and these small chunks have no value at all.
Absolutely, absolutely, Ahmed. I think it's not, totally correct to have a hard limit on the number of lines. You can have a few lines of code that are very complicated, and you can have more than that. That's very easy and to read and understand, etc. And with that, I think we should conclude our session, Ahmed. That will be all the questions we take for now. Let us talk about Tek Caffe services. As you know, we have commitment to technical excellence by teaching and coaching software developers from different backgrounds on extreme programming, on TDD, on behavior-driven development, on how to write effective user stories, DevOps and extensions, refactoring, software architecture, software design, system design, domain-driven design, scaling agile teams, working as remote teams. All of these topics we cover in our workshops and in our consulting services. Here are examples for our on-site workshops, where we had a session about TDD. We applied many of the principles. We had the audience actually participate in the some of the exercises. There's another one about domain-driven design and behavior-driven development. These are examples from our online workshops for individuals and corporates as well. Feel free to contact us and try some of these workshops. Another one about modern extreme programming applied. On our website, you can learn more about Tek Caffe. So please go check our website to learn about our services for corporates and individuals. Finally, we have a new Agile tool called TDD cards. These are cards that explain the practices under each of the phases of Tek Caffe TDD cycles. Each of these phases has their own set of cards. This is a picture of the card deck. It has more than 50 cards. The cards are grouped in categories or to explain certain phases. They explain the practices and patterns of TDD cycle phases. You can use these cards in different ways. The deck actually contains a card that explains how to use the TDD cards. One way we use it is to measure the maturity for TDD for teams. And there are many other ways you can use it. We actually did an episode in Tek Caffe about the TDD cards. We used a subset of the deck. We applied an exercise. We applied to an exercise on a kata. So feel free to go back and check the episode. Finally, we would like to announce our upcoming episode on Tek Caffe. That's also sponsored by ActionGPT. The episode will be with 𝗕𝗰𝗄 𝗬𝗟. We will talk about domain-driven design, questions and answers with the experts. So stay tuned for that, and we're looking forward to having you there. Finally, I'd like to thank our sponsor, ActionGPT. Feel free to check their website and their tool. I'd also like to thank Maria for being with us today, and Ahmed as well.
Thank you.
Thank you very much, Khaled.
Thank you very much.
You are a great host, and thank you, Maria, very much for being with us today. This was a very exciting session, and we've enjoyed it a lot. I hope you share the same feelings. We definitely want you again with us in a new session next year, inshallah. Thank you for making the time for being with us, and keep being creative and keep doing these great interviews on your channel, and looking forward to seeing you again next year, inshallah.
Thank you so much, Ahmed and Khaled. It was a great pleasure sharing insights with you. And really, I would like to say Khaled was really a great host of the session, and he really had great questions. Some were very challenging and very nice questions. And I hope together we added to the community what we have. And thank you so much. Yes, I would like to join you in future sessions as well. It was a great pleasure.
Very well.
Inshallah.
Inshallah.
Thank you.
Thanks a lot.
Thank you all, and we'll see you next time.
Allah Hafiz.
Bye-bye.
Allah Hafiz.
Bye-bye.
Allah Hafiz.